Hi everyone, this is Elias from the Minima development team. Today I will be talking to you about how I built the Wallet MiniDapp. I will be talking first about the technologies I used, the prerequisites, how to create and set up the project, how to run it locally and set up a development environment. I will be running through every page of the wallet and then explaining the um, features with the code. Then I will show you how to build and install the MiniDapp. The technologies I used are React with TypeScript, and for state management I use Redux. So the prerequisites are Node.js and Java. Node.js to create and build React projects, and Java to run a local Minima node. The first thing I like to do once I create a new project is I make sure I set up all the MDS little things, so then I can start using Minima immediately. So the first thing I do is I go into the public folder, which comes already with shipped with the create React app command. You will have MDS. We can copy over MDS a JavaScript file. And keep in mind that everything I mentioned in this video, CLI commands and resources, I will include in a document attached to this video. So in this JavaScript file, we have this MDS object. Now we want to make this MDS object available to the rest of our app. Simply, we just need to add this as a script in our index.html file. So now that we have MDS available to the rest of our app, we'll go into our source folder. In here there's two important things we need to do. So if we are using TypeScript, we need to declare MDS as a namespace. Otherwise, our application will not know what this MDS object is, and TypeScript is going to complain. And besides that, let's have a look at this events TypeScript file I have. So what this file really is just a wrapper around MDS. Because we're using TypeScript, I have a bunch of interfaces, and they are all kind of defining the objects coming back from every events of Minima. It just makes our life a little easier, because then we know exactly what data we're looking at when it comes time to developing. Now this file we are going to be looking at furthermore down the line. Just let me first take you through how I initialize Minima. So where I like to initialize Minima is, you have to do it only one time, and it will have to come from probably the first component, which is rendered. Now the first component rendered is the one holding the rest of the application, is the app component. So in here I have these components, and I have my app navigation component. This app navigation holds some routing for the app. And then at the top of here, you will notice I have this hook called use minima status check. So this is a custom hook that I wrote, and in here I do an events on init. So this events on init essentially calls we're getting this events object from the file I showed you earlier, the events TypeScript file. And there's a function on this object called onInit. That's a callback function. If we have a look on this thing, we call it, and it runs this initialize minima function. So obviously, if we're running something in there, it's going to run this callback function, and at the same time, it's going to initialize minima. What is this initialize minima function? It runs mds.init, Now keep in mind we could have simply just ran this, outside of this events object without having to do this extra hook stuff. Then let's go back here. As you can see, I do some initialization of things. I set node status to online, I set MDS status to online, and I dispatch some Redux functions as well. As you can see, I first run Minima. I make sure the MDS web server is up and running, and then I'm allowed to use MDS's functions. So in here, call and store balance and call and store tokens, I'm doing a MDS command. Let's look at it. I'm running get wallet balance, and what get wallet balance is running an RPC command, and this RPC command is running mds.command. We go down here, mds.command, and then we tell it. So I have created wrappers around it so they can be reusable, so we don't have to run or create mds.command every single time we want to use a function. So let us just take a step back. Let's go back to where we were. And so yeah, so now we have MDS web server running. We have initialized a couple of things for the rest of our application. And then down here you'll see events on fail. So what events on fail does is if MDS at any given point it's not, the web server crashes or it's not running anymore, we will receive an event as all other events, and we can appropriately display something on the front end so the user will be notified. Setting up a local dev environment. To set up a local dev environment, we need to first run the application locally. We can do that by doing npm run start, and that's automatically going to build a project and then host it on default port 3000, which is React's dev server. After having done so, we will realize that we launched the application, but MDS is not connected. We need to make sure that we hard set the debug port to 9003, and then we fetch a MiniDapp UID, and we also hard set that, and then we can use that MiniDapp's UID to make RPC calls from our local dev environment of React. So let's go ahead and do that. Maybe it sounds more complicated than it actually is. We'll just do npm run start. As you can see here, it's going to launch the project. This is the wallet. But as you can tell, fetching your token is taking a little while. It shouldn't take this long. It didn't work because it's trying to connect to port 3000 for MDS. Now, obviously, you're like, but we didn't run a Minima node, and you're right, we didn't. But even if we do, so let's run one. Enable RPC, enable MDS, MDS password. Well, clearly, we need to run a node so we can talk to our node, right? But we're just going to have to do one more thing after running a node. So I ran a node now with Genesis, no peer-to-peer, enabled RPC, enabled MDS, and I set a password for the mini hub. Okay, now it's all enabled and it's running port 9003. Even if we refresh now, still trying to connect to port 3000. So what we have to do is hard set these settings here before MDS init. You can see these three variables: debug host, debug port, and debug MiniDapp ID. If we go into our MDS JavaScript file, we will notice three different variables here, and these are the ones that we need to hard set when we're debugging. So we set localhost to 127.0.0.1. We set the port to 9003, and because the node's running 9003, and the MiniDapp ID we need to get from a pre-installed MiniDapp on the hub. So let's access the mini hub. And let's install a MiniDapp. And we need to get this hash up here. So this is the UID of the MiniDapp. We copy that. Then we can just close this one, it's fine. And we just set it here. And we save the file, right? So now if we go back to the wallet, we notice that it works. You know, the RPC goes through. We're getting all the data back. And yeah, now we're ready to develop and communicate with, interact with the node. Okay, so now let's go through every page on the wallet and then just go through what is happening behind the scenes. So we have the balance page. The balance page essentially just shows us the tokens that exist in our wallet. If we go to our node, to the CLI, and we type in balance, we get back a response with all our tokens. Token, minima, token ID, confirmed, sendable, coins, total. Now we only have this token, right? Now if we create another token, we now get another token, right? And if we type in balance again, now we have two tokens. We have minima and we have a custom token called testing. And we can see it here being displayed. Now, what is going on code side? If we go to the page, we go to the balance page here, balance, and then this is our balance component, and we have a grid layout, and we go to wallet. We scroll down to the wallet component, and what do we see here? We have wallet tokens, right? And use app selector, select balance. So this line is essentially just using a selector. This is a Redux kind of thing, as I have one source of truth for the balance, because there is multiple places in the wallet which access the same information. It's preferable for me to access it this way. But if you didn't want to use Redux, for example, you can just load the balance this way. So mds.command balance and response. In this callback function, you can just console log response.response0.token. That's just going to print out minima, right? So if we go back here, we're essentially just getting back this JSON object, and we're accessing the first one in the array, 0, index 0, and we're accessing token. However, in Wallet, because I use Redux for state management, if we have a look at what's happening in this selector, we come here, return balance, return state balance fonts. To those of you who know how Redux works, you'll understand what a selector is. But where I'm actually loading in the data happened in the events.onInit that we have seen earlier. I do call and store balance, and when the application launches, I call balance and I store it immediately. So what happens here? There's a promise. It calls get wallet balance, runs RPC balance. What does RPC do? RPC essentially just does mds.command, as we can see here. mds.command. Any command we run will return us the data. Now, since I store it in my Redux store, I use selectors to access it from any component in my application. Now let's have a look at the send page. So the send page in the wallet, some of you may know, some of you may not know. You just send tokens. It can be minima tokens or it can be custom tokens. And you can also, there's another feature which you can coin split. So you can make this coin split to two instead of having one coin to put into a transaction, because transactions are made up of inputs and outputs. One input is one coin, two inputs are two coins, and you can have multiple coins. So you can split up coins, so then you have more than one coin at a time. So if you wanted to do two transactions at the same time, you need two different coins, because the nature of how blockchain works, you need to wait for the coin output to come back before you can use it again. Right. So send page. Let's go back to value transfer. So now we want to send some minima, right? Let's see what happens, and let's see what happens here. First, let's get an address. Let's get our address. I copy this address, right? I want to send 10 minima. Continue. Accept. This action is now pending. Okay, let's go back to the hub and accept this transaction. Accept. Perfect. So now we have sent this transaction out. New balance update. Let's go back to the code editor and let's look for the send page. Go to the send page. So the send page, once again, send component has a grid layout. Uh, Inside this grid layout, we have two options, as you saw before, value transfer and coin split, and our two different components, which will be loaded. Let's go to the value transfer component first, because that's what we used. So in here, I will briefly take you through it. So we have, once again, we access the wallet balance because that's what we need to display the balance here. QR scanner stuff. This is the vault locked? If our vault is locked, then we display another input field down here with a password. Fortunately for now, we don't have it locked. Some extra stuff which I perform some validations and checks. And then we have Formic here. I use Formic, which is just a library to create forms. And if we have a look at what's happening down here, call send. So this is the main, this is the RPC command I'm performing, so I can send out transactions. So when you hit send, when you hit continue and then send, I'm calling this function, which is taking in submissions from the form. I perform some checks here. Does it have a password? Does it have a burn? Then I do RPC once again. And this RPC command is a send. So send, amount, address, token ID, has burn, has password, depending what the RPC will be. And the RPC is going to return a response, right? So what is essentially happening? Same exact thing. Send, amount, as you can see in the CLI, 10, address, this would have been my address, and token ID OXOO. No coins of token ID available. Okay, so we have to wait for the coins to come back. As we mentioned before, if we had split the coins, maybe we would have a coin right now to use. But we just have to wait for the block to come back with a token. So essentially what we're doing here is the same exact thing we're doing in here, except, this is happening automatically in the background. We have a nice GUI, so we can just, hit the button, does it for us. We don't have to type it manually here, and all the checks I'm doing obviously makes it easier for a user to send out transactions. Okay, so now let's go over what's happening with CoinSplit. CoinSplit is essentially just sending money back to us and splitting the coin in two. There's a function on our node which essentially does that for us. get address. If we do get address, we get an address, our own node address. Send amount, I'll send 1 million to my address, token ID OXOO, which is minima token, and a split 2. So now I'm just sending back the money to myself, and I'm splitting that coin in 2. So now I have 2 coins worth 500,000, 500,000, and I can use both of them at the same time to perform 2 transactions. And yeah, so this is what CoinSplit is doing for us essentially here. If we go back to the send page, the send component, and we go to CoinSplit, we will see this exact thing that I was talking about, right? So again, we have, CoinSplit component. I'm accessing the balance from the selector of Redux. I go down to the Formic object. I have a look at the split coin. What is split coin? Let's go on to split coin. As you can see here, I call get address. What is get address? Get address is doing RPC get address. So as we saw earlier, I use the RPC command get address. If we do get address here, boom, it's going to return and get address for us. Let's go back to get address up here, and it just returns us a mini address, right? So I go back here, gives me a nice address, perfect. Then I go down here, and I run another RPC, send to my address, token ID, whatever token ID we're asking for, OXOO in this case, and this is the amount to send back, and I split it by 2. Now obviously if we add a burn, the reason this is different, final amount to send, if we have a burn, we want to burn a bit of minimum on the coin split, there's going to be less amount that comes back to us because we have burnt a little to pay the network fee. Now if you keep the burn 0, the burn is 0. We don't need that. And that's pretty much it, that's pretty much it. Then we reset the form and done. Now let's have a look at the receipt page. Pretty straightforward, even easier than the other page because this one literally just calls get address, and it calls scripts on here if I'm right, and we also have a little form which performs a check address, which is another function which the node gives us. So we just go to the receive page, receive component. Okay, here we go, receive component. Obviously, those of you who know, some state state variables here, get current node version. So here I just check what version this user is running, because this feature here requires a certain version to be run of minima. Check minima address. This is the function I do to check an address which they've given us. Clear form, just basic stuff that sorts out a bit of the UX. Now the main feature, the one where we really are looking for is, so we have this address and we have default addresses, and yep, so use effect, it runs get scripts. So what scripts does is essentially just runs this command, returns all the scripts, and we are looking for all the default 64 addresses created for us in the beginning. And this is exactly what's happening here. Get scripts returns us all those scripts you see here, and then I filter through them. Simple JavaScript, functional, get the simple one and the default ones. So what does that mean? Get simple true and get default true. All the ones that return simple and default true, get all of those for me. Then I set the default addresses. Now if you have a look here, these are all the addresses we're looking at. and set address. I choose one at random every time you load the page. Every time it changes. HKPN 808 MT9. So I select one out of the 64 and I display it there. Obviously the QR code changes according to the address. You can copy. You can use it to send. You can give it to your friend. He can send you some minima. Done. And then you can paste it here and check address. Now this is just a form just to tell you whether the address is good or not. We can put a wrong address. Valid address, no. Reason, it's just a wrong address. We gave it a bad address. Let's put back the good one. Returns okay. Same concept. We're running another RPC method. So if we have a look, get current node version, check minima address, we're running this check address RPC command. If we go into it, MDS command, check address, just another simple MDS command, and resolve the response to us, give us back the response, and we handle it in the front end. Status page, same exact concept. Let's have a look at what's happening. Overview. We get back essentially this JSON object. We're on status, bunch of JSON comes back. We're like, okay, let's have a look at the status page. Yeah, we have some custom components that I've written. Okay, literally call status, return status, set status, and then I render everything down here. Okay, so if we go back up and we go into the call status function, same concept, await RPC status, we go back to status, mds.command status, returns us back the response, and we can do whatever we want with the data. So now let us look at something a bit, more fun, more complicated. The create token page. So the create token page and the create NFT page are almost the same thing. It's just one token is differentiated from the other one. One token can have decimal places, the other one cannot. You cannot send it as decimals. It can only be sent as a whole. So if we have a look here, upload an image file. Okay, let's upload something. I don't know, any picture that I have. I hope I have something suitable. I don't know what that is. Okay, let's use something from the brand. Maybe I have an SVG here or something. Oh, we have the old. Okay, we have the old logo here. Cool. Enter name. Fake minima, and let's make a lot of it. You can add a description, a ticker, la la la. We hit create. Fake minima. Not set. Burn. Okay, let's go. Pending transaction once again. Let's accept this. Cool. Accepted. And while we're here, let's just make our application right. So now I made it right. I don't have to come back and do the pending stuff. Okay, we created this custom token. Let's go back here. Fake minima. Cool. So what happened now? Let's go back and look here. Very simple. Token creation. Once again, we have the token creation component. We access the balance just so we can check at the top. We check here at the top whether we have enough minima to create one. Use is vault locked. This is also a check. Set field value, funds, wallet. Do a bunch of stuff to initialize the form. Then we have this formic. I like to use formic. You don't need to use formic, but I like to use it. Then we go down here and build custom token creation, right? So I would say this is the most complicated part of this whole form, just because we do a bit of compression. If we upload a file, right, and we upload a pretty relatively big file, like full HD image, 4K HD image, and we want to squeeze that so we can send it in a transaction. Um, Now, obviously, if it's too big, then the transaction is going to fail. Uh, there's a maximum size of how much a transaction can be to fit in a block. If it's too big, it's going to fail. So we try to compress it as much as possible, so it can go on the chain. So what is happening here, right? We'll open up this function. There's a lot of stuff happening here. So if this data is a data URI, then compress it. Perfect. If it's not a data URI, obviously if it's a URL, then just create the image, create the token, where we don't have to worry about any compression. However, if it is a actual data object, then we need to compress it. We go into here, get suitable image. We do a bunch of compression stuff, create image. The source code is online. You can have a look at what's going on. But what we're essentially doing is a bunch of uh, using canvas to get a context. We resize it by doing some compression. We redraw the image and then we turn it back with a lower quality. In our case, we're using 0.8. But after we have done all of this, we'll get back a smaller, more compressed object. And then we can use the create custom token, which is an RPC command, to create this token. If we go here, create custom token, what is happening? RPC, as usual, token create, name, amount, decimals. Decimals matters if it's an NFT or a normal token. Um, web validation. To those of you who know, web validation would essentially give you a way to verify that this token is in fact yours by putting a small txt file on your server. But yep, and so what happens? Token creates a token for you. Very simple, and it's done. So in here, in the name, we pass in essentially just a JSON object. It will have in the description, it will have in the URL or the compressed image that we created. It will have anything else, the ticker, everything all together is going to become a string. We're going to fit it into the name. Obviously, it's a string, JSON string, which can fit in the name. So if you can see here, token create name, and then we do name alias, then we do description, blah, then amount, we'll make 1000 of it. Okay, there we go. So it created it for us. New unspent coin, new balance update, alias, that's the one we created. So nothing more happening here. This is exactly all we had to really had to go through. Right. Okay, so let's have a look now at NFTs. NFTs page. Collection, favorited. You hit create. Same concept, same exact thing. The only difference, as I mentioned earlier, is on the NFT page, we create a custom token with decimals set to 0. So we don't allow, so you can only send 1 of 1, or you can send 10 of 10. You can't send 10.5 of an NFT. A picture can be divided by 1 if it's an NFT. It's 1-to-1 with whatever this NFT is trying to represent. A ticket for a concert. It can only be sold 1, not 1.5. So, you know, I'm not going to put any image for this, but let's say ticket for, I don't know, Jay-Z. I'll create 100 of them. Creator ID, alias, description, ticket for a concert. And then we mint this NFT, accept, created. We go to our back to our NFTs page. We have a ticket for Jay-Z by me. Uh, we have 100 of them. Total minted is 100. Okay, great. We go back to our balance. We have a ticket for Jay-Z. And yes, okay, it's not confirmed yet, but that's pretty much it. So now that we have went through all the pages, let's have a look at how we can build this MiniDapp. Let's say we're happy with, we just added a new feature. We're happy with what we did. We want to build the MiniDapp. So how I go about it is I obviously have this MiniDApp folder in which I store the latest and greatest version. And then if you go to package.json, I have this build zip uh, command. And the way this happens is obviously before you build, you have to make sure that you deactivate, remove these debug variables. Otherwise, it's gonna cause issues. Yeah, I removed it, commented them out. Okay, so now I do npm run build zip. What this essentially does is it runs build. React does its thing, builds all the source files, webpacks everything, makes one big JavaScript file, and then I remove the previous version, I cd into the build, I zip it up, then I just move the latest version. Obviously, if if we have another new version, we do 20, it's gonna be 20 now. And what this essentially does is it CDs, it goes into this folder and just zips it up with what? You need to have this dapp.conf file. What this dapp.conf file is give a configuration when you install it into the mini hub. So you get a name, an icon, a version, description, browser. So you need to make sure, including the mds.js file, that you also have this dapp.conf file. So it zips up everything. You can name it whatever you want. .mds.zip. This is our naming convention. And then you can simply just install it. So if you go v2 wallet MiniDapp install, and there you go. So now you install the MiniDapp and it's ready to go. Thank you very much for watching, and if you have any questions, feel free to ask down below, and have a great day.